Hi, welcome to ClickMyProject.com. Our process is delay analysis of multi-channel opportunistic spectrum access MAC protocols. Abstract: a comprehensive delay and queuing analysis for two baseline medium access control protocols for multi-user cognitive radio networks with homogeneous network users and channels is analyzed and investigate the impact of different network parameters on the system performance. In addition to an accurate Markov chain which follows the queue status of all users, several lower complexity queuing theory approximations are provided. Accuracy and performance of the proposed analytical approximations are verified with extensive simulations. It is observed that using an Aloha-type access to the control channel, a buffering MAC protocol where in case of interruptions the CR user waits for the primary user to vacate the channel before resuming the transmission. It outperforms a switching MAC protocol where the CR user vacates a channel in case of appearance of primary users and then compete again to gain access to a new channel. The reason is that the delay bottleneck for both protocols is the time required to successfully access the control channel, which occurs more frequently for the switching MAC protocol. Let's see the flow of initially the node creation and channel creation will take part. After that, the packet request from the user is partitioned into multiple packets. Then each packets will be transmitted based on the node and the channel allocated for the packet. Then the buffering protocol or a switching protocol will take place to transfer the chosen packet based on the user type, whether the primary user or a second user. The buffering protocol or a switching protocol will utilize the packet to transfer the data from server to user. After that, if it is the primary user, the buffering protocol will calculate the state variable for combined Markov chain model, and it will forward to the server cycle analysis process. There the probability of successful reservation and the successful transmission will be calculated. Likewise, if the user is a second user, that is cognitive radio user, the switching protocol will take part and forward the packet from server to user and calculate the state variable for occupancy Markov chain model, and it will forward to the server cycle analysis. There the successful reservation and the probability of successful transmission will be calculated. Let's see the demo for process. Initially run the requester process. If the user is a new user, click on register here button and provide the username, password and get system details. Click on this button and click on register button. The details will be registered successfully. To get license from the license provider, click on get license button and run the license provider process. Here provide the username and click on send request button. The server is connected and the request is sent to the server. Here by clicking on to know the details of the requested user, click on user details and it will get the system IP and system name, and click on generate license button. It will generate the license for the requested user. Then click on send button to send this to the requested user. Here the license is fetched from the server, and click on store button to store the details. The license value is successfully stored. Then click on OK and click back. Here provide the username and the password to get login. If the user is a primary user, he will have the license. If the user is a second user, the license is not provided. Then to get data from the server, click on get data and the list of files will be displayed here. To get any one of the file, click on select any one file and its file name and the file size will be fetched here. To send this file request to the server, run the delay analysis process. Here provide the number of node value and the channel value and click on create button. The nodes will be created and the channels will be created. To load the data into the server side, click on browse button and fetch any one of the file. The file will be added into the file collection. Then click on next button, click on view button to know the node details and the channel details. Now to receive the file request file from the user, click on send button at the packet request and receive file request button here in the server side. The request is sent and the requested username is Sri and requested file is 1.txt. Then click on OK, and then the server will find out whether the requested user is a primary user or a secondary user. Then click on OK, choose the requested file and click this button to get the content. To partition the requested packet and send to this user, click on this button and enter the number of partitioned count and click on partition. The 3 packets will be partitioned. Then these are the packet details. Click next button to view the packet information. Provide the packet number and click on view button. Then next, here these are the channel IDs and the packet IDs. Now allocate the channel to the corresponding packets. Then if the packet is already assigned, it will show the error message. Then click OK. To view the allocated channel and the packet IDs, click on view button. Then to know the rest of the allocated channels, deallocated channels, click on rest of channel button. It will show the number of deallocated channels. Then click next. Here these are the allocated channels to the node. These are available node IDs and the channel IDs with the packet ID. To allocate the channel to the node, here choose the channel and the corresponding node ID to allocate it. Then allocate, click on allocate button, and finally choose any one of the node ID for the available channel. Click allocate button, click on view button to view the allocated node for a corresponding packet and channel ID. Then to know the list of deallocated nodes, click on list of nodes. Here the one count is displayed, which is not allocated to the channels. Then click next. To know the reserved node IDs, click on get button. A, B, D are the reserved node IDs for the corresponding packet and the channels. To know the queue performance metrics, click on measure button. It will show the current number of packets in the queue and the number of reserved channels for each packets. Then click on next. Here provide the time slot value to allocate each node to transmit the packet to the user. Click on allocate button. The time is allocated to each node and for the corresponding packets. Then to get now choose the requested user type. If the user is a primary user, the process will be moved on to the buffering process. If the user is a secondary user, that is cognitive radio user, the process will be switched to the switching protocol. Then choose here the user is a type of primary user. Click on primary user and choose the packet to send. And click on state transfer button. It will send the process to the corresponding requested user. Click on start server and start receive button on the requested side. The transmission is a delayed transmission. Click on OK button. Now then send the packet to and start receive button, and finally send the packet to. Next, click on to know the probability of successful transmission, click on this button. It will fetch the probability of successful transmission. Then click on next button. To know the state variable for the busy node and idle node, click on this and click on idle nodes in empty queue button. It will fetch the total number of nodes. Then to compute the reservation success, click on compute button. It will compute the total number of channels excluding the control channel and the maximum of transmission, and this process of successful reservation is 0 and the service time is 4 seconds. By this the execution process is over. Thanks for listening.